In this lecture, we will learn how to represent a graph as an adjacency list in Python. A graph has a list of its nodes. Each node has a list of its neighbors. With an undirected graph, there is duplicate edge information. Each node has precisely as many nodes in its adjacency list as it has neighbors. It's very space efficient because you never store more data than needed. The downside of adjacency lists is that to determine if there is an edge from one node to another, it requires the node's adjacency list to be searched. This takes linear time for dense graphs. The first step is to create a node class. Each node will have a list of its neighbors. We will define the init function for a node that takes in two parameters, self and value, and the value parameter will have a default value of none. Inside of init, we will set self.value to the value passed in when the node is created. Next, we will create a class named graph. Inside of this class, we will define the init function, which will take in two parameters, self and size. Inside of the init function, we will have a vertices variable and set it to an empty list. Then we will have a for loop for I in range size. Inside of the for loop, we will append a node to the vertices list. After that, we will create an addEdge function that has three parameters, self, source, and destination. Inside of the addEdge function, we will append destination to the source neighbors list, and we will append the source to the destination neighbors list. Our graph will also have a removeEdge function. This function will take in three parameters, self, source, and destination. Inside of this function, we will pop the destination from the source.neighbors list. Then we will pop the source from the destination neighbors list. After that, our graph will contain an isAdjacent function. It will take in three parameters, self, node1, and node2. Inside of this function, we will return true if node2 is inside of node1.neighbors, and false otherwise. That wraps up the code for our graph class. Outside of the graph class, we're going to create some nodes, then create a graph, and then add the edges between the nodes to form the graph. We will create a variable named 1 and set it to a node with the value of 1. We will do the same thing for nodes 2 through 6. Then we will create a graph variable and set it to a graph with a size of 6 passed in. Time to add edges between the nodes to form our graph. We will call graph.addEdge and form an edge between 6 and 4. Then we will form an edge between 4 and 5. Next will come an edge between 4 and 3. After that will come an edge between 3 and 2. Then we will have an edge between 5 and 2. Next will come an edge between 2 and 1. Finally, we will have an edge between 5 and 1. In the next lecture, we will learn how to perform a breadth-first search on a graph.